WMG are leading the way in connected and autonomous vehicle research. They have unique research facilities and CAV infrastructure testing with real-world environments, as well as a state-of-the-art 5G testbed that is used by Midlands future mobility users, as well as automotive OEMs. Part of the CAV testbed here at WMG is utilising the Rohde and Schwarz vector signal generator SMBV 100B, as well as the FSVA signal analyzer. Both of these instruments are used in over-the-air test measurements.
We're in the Connectivity and Communications Technology Lab. So one of our primary research objectives here at WMG is to understand how future connectivity and communications technologies affect future vehicles such as these autonomous pods. So government and industry has identified a number of socio-economic impacts that can be achieved through the acceleration of connected and autonomous mobility solutions into the UK. These can include increased safety and a lower level of emissions, for example. In trying to achieve these aims, there's a number of technical challenges that are often needed to overcome. One of those is around connectivity. That is, how does the vehicle connect to the wider network? Here at WMG, we are trying to accelerate the understanding of our partners to increase the level of connectivity within their future products. Those questions could be around where do we place the antennas, what materials might we use around the vehicle, and how does that affect its connectivity performance on the wider network. We might be working with partners who are transmitting to the vehicles and need to understand the best waveforms to use, how we might optimize the network. Part of our need here at WMG is to be able to offer a flexible solution that solves our partners' problems as they arise. A particular research challenge, for example, around 5G is that we have to consider it as an ecosystem. So we have a number of infrastructure providers, we have a number of operators, and we have a number of vendors at the vehicle end that all need to understand each other's needs and capabilities in order to deliver an end-user solution. By having access to a broad range of equipment, we here at WMG are able to understand either those questions individually at the component level, we can broaden them out to the system level, or we can look even wider to the national level when we include policy understanding. So as part of the Zenzik Midlands Future Mobility Testbed, we are using a Rohde and Schwarz solution to answer some of those questions on behalf of our partners. Using the Rohde and Schwarz vector signal generator and vector signal analyzer along with the 5G software package allows us to answer the very specific questions around the 5G powers, the bandwidths and the numerologies which we might be applying to the vehicles. The benefits of the testbed along with the associated equipment really allow us to drive forward the autonomous vehicles from the lab space into the real world and thus deliver impact to society. The team here at WMG is really excited to make sure that we can accelerate that process as fast as possible.
We are delighted to be a WMG application partner, working not just on automotive applications, but also now on 5G smart factory research. We now look forward to further development of new ideas from WMG, with Rohde and Schwarz solutions being an integral part.